So I'm going to talk about Epoxy. It's a library from Airbnb, and it helps us basically with these really complex recycler views that we have now. But before I get into what that actually does, I'm going to talk about why we need it. It depends on how long you've been doing Android, but you might have back in the day used an array adapter with just some strings in it and put it in a list view. And it looks something like that. And I think that's basically what they were designing list view and the adapters for. But now we have stuff like this, where the Play Store, where we have tons of different types of items. It can scroll horizontally. You're loading images. You want to make sure you're not keeping way too much stuff in memory. Let's see. So they came up with Recycler View, which has fixed some of these problems, especially around like animations. Trying to do animations before in a list view was terrible. That's a lot easier now. But one thing that's still a problem is that our adapters are complicated, and this is one small adapter, and our thing has 6, 7 different item types. And the logic for deciding which item type you're on is complicated. It just goes on and on. So you're in your adapter, you've got all these switch statements based on what type of item you're at. And then we have stuff like a switch statement for on create view, a switch statement for on bind view, stuff like that. And then also, like, if you click on one of the items, what do you do at that point? You probably have to go dig through some data structure somewhere. And then if you do anything like notifying when like an item gets inserted into it, so you can have like nice animations, then you have to have a lot of complicated code for tracking which items have changed. And then, so you've done all that, and then suddenly a product manager's like, I really think that we should have sections in there, and I think that they should all be collapsible, and you have to like redo all of the stuff you just done. So when you have problems like that, that means you probably are using the wrong architecture for it, because really we want a single responsibility for our adapters, so that they don't have to change in a bunch of ways whenever we change some small piece of like ordering or inserting some new type of item in there. So if you had to sum up what the responsibility of an adapter is, can anybody give me like a sentence? What's an adapter's job? Well, then they're accomplishing the job and working according to plan. But
data to bind to a view, right?
Yeah, right. So you've got some data, you want to bind it to a view. So I've always been confused about what it should actually do. Like, there's a lot of stuff that ends up in there. So here's some stuff that you shouldn't do. I've seen them managing state. That happens all the time. I've seen them do navigation, like they clicked on an item and you figure that out in the adapter and try and navigate to a new page from there. There's places where we are somehow kicking off network calls just from like inside of the adapter. We should never be doing that. So those are things not to do. Here's my attempt at saying this is what an adapter does. So you have some complex piece of data, like some data structure. You turn it into a simple list, because that's what all you can see on the screen is a list. And then for each item in the list, you associate it with it. The reason I say that it's a complex data structure into a simple list is, even if you think you just have a simple list, like a list of names, you probably also have something like, has there been an error? Is there like a loading page showing? Is there like an empty state that you show, which you probably should for basically any page. You have error states, you have loading states, you have empty states. So because of that, you do have some complicated data structure, but eventually it needs to end up as a simple list. So I'm going to, and the other point is that you should, whatever data you have, you basically want it all in one spot, so you're not like looking things up inside of your adapter, checking the database for any reason. You basically want to grab all the data up front, every piece of information that you need to render those views onto the screen. So here's an example of what I mean by serializing a complex data structure into a list. Say we're calling that set data method, and we have a list of people. It is loading some more data, they scroll down maybe and we're loading some more. And then there hasn't been an error. So what that data structure turns into is, but we end up with, you put a header on the screen, you have these 3 people, and then you have like a loading view down the bottom. So that turn into like a 5-item list just from this right here. Here's another example. So say you have no people, but you are loading, and we show the empty state, and then at the bottom we show the loading state. Or if there's no people at all, we're just showing the empty state on the screen. But either way, it ends up turning some complicated amount of data into a simple list of different types. So now we have the other half of the recyclability's job, and that's to take, now that we have a list of the types, we need to associate those with a view and bind the data to the view. So that's like an onCreate view holder and an onBind view holder that you've probably written. But those turn into these big switch statements where you're inflating views and all that type of stuff. So as an aside, from the architecture talk, what layer does an adapter live at? I say it belongs strictly in the view. It should be doing essentially nothing else besides those things. It can also potentially like bind a click listener, so they might receive some user input and then need to pass that back up to the presenter, which decides what to do with that. Can I scroll this? Okay, so that's kind of the reasons why that recycler views are complicated. So does anybody have questions on that part, like why recycler views are complicated and what like the solution that we're looking for should do? Has anybody had a recycler view that was doing all the like network calls and stuff like that?
So what about the console? Have you considered network calls? Like if you use a library like that.
The black box.
Yeah,
You, oh,
that's true. Yeah, I kind of just considered part of it.
but that's still making network.
but it's black box, meaning, yeah, it's probably breaking all of your architectural design, so it's a third-party thing that is self-contained. And
Because
all
you don't really
see
even know that's
is
making
network.
network. All you know is you're saying split this image this view.
Yeah, you know that it does network stuff, but if you didn't know, it wouldn't make a difference on how you use it. And it doesn't break your paradigm because it's a third-party thing that you're using just in here.
So now let's jump into what Epoxy is. So it's from Airbnb. I don't know if you see their app, but it's actually really nice. But it has these really complicated layouts where you have like some destinations that you can swipe sideways on, but you also have all these like other things you can do. You can reserve homes. You can reserve these like experience things that they do. You can, I don't know, probably get flights or hotels in there. Who knows? But it does follow this pattern I described where you're creating a simple list of model objects, and then for each one of those, they get associated with the view. And it does use unidirectional data flow. So if the state changes, it's going to notify the adapter. Well, they're called controllers in Epoxy, but it's basically the same as an adapter. It notifies that there was a change there, and passes in all the data that it needs to know about. And then it's going to rebuild this list of models. And then internally that will figure out which items we need to actually display on the screen. And you can't just directly, like in a recycler view and adapter, you could just, like they click the star button, you could just directly change the star to be like a build-in star. But not with Epoxy, you have to tell the state that was changed, and then it renders that back down the chain. So yeah, that's okay. So the way you set it up is really similar to like a regular adapter. You create one of these Epoxy controllers. You get your recycler view, like find view by ID, and then you'll do recycler view.set adapter, and you'll do controller.grab the actual adapter that's grabbing internally. So that's all. It's not very different to set up. So the job of the Epoxy controller is to take all that data and turn it into a list. So this is done through a method they have called build models. So it takes whatever state it needs and then returns this like flat list of Epoxy models. So we're going to look at an example of that. So this is the data it takes. It takes a list of people, a Boolean for whether it's loading or not, and a Boolean for whether there's been an error or not. So this first part is, if we have an error, we're just going to add an error view onto the screen. Actually, sorry, one thing I should have mentioned. If you're curious about what these this person view model thing is, or loading, empty, error, I'll talk about this later. Those are Epoxy model classes. But so if there is an error, all we do is add the error to the list. So it's basically a list of one item, just an error object. So otherwise, if there's no error, we're going to check if there's no people in the list. If there's no people in the list, we're going to we're going to add the empty state to the list. So if a list of one item, just the empty state. Otherwise, we're going to add a header item to the list. And then for each person in the list, we're going to add a new item to the list. So at the end of that, we have header item, person, person, person. And then if we're loading, we'll throw a loading item down at the bottom of the list. So say we have 3 people in the list and we're loading more. We'll have a header, person, 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 and then a loading down at the bottom. So whenever you change your data, you have to call that set data method so your adapter knows about it. So that's very similar to notify data set changed in a regular recycler view adapter, but it actually takes the data that it needs as parameters to it. So that's nice because you know this is all the data that I need to render my views onto the screen.
So that both sets the data set and notifies at the same time?
Yeah, when you call set data, internally it's going to
Trigger both of those calls.
trigger both of those things, yeah. So again, this is the only way that you can change the views or data in the Epoxy controller. You have to call set data. You can't just mutate the state of the view or anything like that.
Does it update the views individually? Is it using diff U2s under it?
So that's the next slide. Yeah, underneath it automatically diffs to figure out, because you're basically rebuilding a complete list of models, but internally it knows how to compare models and see what has changed. So it'll do all the appropriate and I think they wrote their own diff utils that they say is faster. Sure. So that may or may not be true. But so it'll also do all the nice notify item inserted, notify item moved, all that type of stuff. So you get the cool animations just basically for free. So one other thing is, remember I was talking about how say you want to go add sections and that's a huge pain, or any other type of view. With Epoxy, it's basically as simple as I'm going to create a new model class, and then in my controller, I'm going to add this new section view. And I don't have to change anything else, no changing the count, no bind view, no create view, one place. So I think that helps us with keeping the adhering to the single responsibility principle. Because Epoxy controller really only has one reason to change, and that's because the ordering of the views has changed, or you're adding new views, or you're taking views out. And that's really all it does. So now we're going to look at those the models that are associated with that we were basically adding to the list. So there's a bunch of different ways to define these model classes. You can basically, I guess I won't go into all of them, but you can create just a data object that extends Epoxy model, and it will, and then you have a bind method, and it takes the data. But that's if you don't want to use their magical annotation tools. But the easiest way to do it is just use their nice annotation stuff. So you basically create a custom view class for each item type, and then you're going to add some annotations to it for whatever the properties of that, the data properties that go with it.
So why would you not use their magic annotation stuff? Is there a use case for that?
I think just if you want more control, honestly, or if, because I actually started using Epoxy before this came out of the Epoxy 2.0 release a few months ago. Before that, it was a little more manual than this. And because the core concept is basically that each item has a model type associated with it. And all the model class does is it knows what data I have for this row and what view, what layout does that go in. and then how do I take the data and bind it to the layout? So that's what a model is, like a layout ID, some piece of data, and a method that binds them together. So you can do it manually that way if that makes more sense to you. Here's an example of how to do it with their custom annotation stuff. So let's just jump into these pieces. So you annotate the whole class with model view. And then this auto layout thing is basically it's a helper, so you don't have to create a separate layout file that's just wrapping. Like a lot of times you have to make a layout that's just a person view, so it knows how to relate a person view. And this helps so you don't have to make one of those. But you don't have to do it that way. So then this is your regular, like you create a custom view. It has a text view name field there. And I'm using butternut here to find it. So that's not Epoxy, that's just regular Android custom view stuff. The Epoxy part is you add this property here. So you add a set name method. It tells the name view to set text, and then you annotate it with this text property annotation. So there's like different types of properties. It's mostly just text property, and then anything more complicated than that, they have another one, just called model prop. And that can take just random, or not random, but like arbitrary piece of data and provide a property for it. So what gets generated is this person view model class, with underscore at the end. So every view model has an ID, so that you're required to set. And then for any of these property annotations you added, it'll add this name method to your view model. And also potentially you could add as like one of the fields a clip listener to it. So then if we go back and look at our Epoxy controller, this is where we're creating one of those new view models from one of the generated classes and adding it to the list. So that's like the basics of how you use Epoxy. So any questions on that part?
Kotlin, how does it play with Kotlin?
It works with Kotlin just fine. Yeah. I have a demo project where I use Kotlin, so we'll see that in a second.
Yeah. So how heavy is Epoxy? If you want to introduce it to your app that you've already got, is it pretty intrusive or is it pretty lightweight?
But the new version of all these like annotations and stuff feels a little heavier to me. But you don't have to use it anywhere you don't want to. It's not going to affect your other adapters, whatever ones you're specifically using. And internally, what it's doing is not really that complicated. Like it has internally, what it is like a list of Epoxy models, and all the other stuff is just helpers for like dipping between those. In the old version, you could just directly modify that array of Epoxy models and then tell it that there was a change. But in the new one, they changed it so it's like unidirectional data flow, and all the Epoxy models are like immutable data structures, so you can't modify them without going through the immutable data flow or unidirectional data flow.
So is it like, what size wise is it? Does it have like a lot of methods, does it add a lot of methods to your application, or is it fairly few? Like how big is the?
Don't honestly know what the current method count is. I think it's relatively, like when I looked at the source code before, it was like it wasn't that bad. They've added a whole bunch of new stuff recently. Like, I don't know if you've heard of Facebook's, I think it's called Lottie, their library, but, yeah.
Lottie,
Something else called Lottie.
Airbnb.
Lottie by Airbnb, yeah.
It might be,
Lottie is the
it's
animation.
one of those, but yeah, so they added support for that. So there's like a bunch of extension pieces to it that you can pull in if you want to. It might work with Litho, I can't remember. So let's jump into the little sample app here. Let me make this mirror. Gonna start my emulator. Well, we can look at this code while it's happening. So here's kind of the whole setup process. We find this, we get this perspective view, we like set up a layout manager, item animator, and then grab the controller out of the adapter. Sorry, this is code in Kotlin, in case that wasn't obvious.
Wait, why are you using find view ID and not synthetics? That's not playing with synthetics?
You used to have to include a separate library, but now it's part of the problem. Technically.
Okay, yeah, you could use synthetics. So what I'm setting up here basically is just, I'm using RxJava just to create like some delays in between this fake network calls I'm making. So initially we'd like show a loading screen, then we'd show a piece of data and then the loading item at the bottom. We'd show some more people, we'd change the ordering of the people, and then we're going to show an area at the bottom. And so just to dive into what each one of those does. How do I So this is that set data method I was showing earlier. It takes in a list of people, and then this is whether it's loading or not, and this is whether there's been an error or not. So each one of these is basically just a set data call with different pieces of data in it. Oh. Let's restart that. So here's the people. It's like a loading down at the bottom. Really easy to add these headers. Oh, here's some more people that have showed up. And then it's going to swap them around and finally display an error screen. But the cool part is we didn't have to really do much at all to get all that to happen. Like the animations just kind of automatically, it does the most efficient form of like notifying what has changed. And every time we tell the controller what the data is, it's, I guess let's jump into the controller right now. So here's our controller. These are the static ones that are basically don't change, and this auto model annotation tells it to create one and give it an ID, so we don't have to do that part ourselves, but you could just as easily create a new heading view model right here and then set the ID to be some random long. But I guess this is just a convenience thing that they add. And so you probably saw this method in the slides earlier too. We told it this is the data that we need to build up the list, and then we check if there's an error state, add the error state, and then don't do anything else. Otherwise, we add the empty state if there's no people. Otherwise, we add the people, and then finally, if it's loading, we just have a loading state. Yeah.
What if your list that you're feeding the adapter with has more than one view type?
What do you mean?
So sorry, so let's say person extends person base, and I also have another class, I don't know, Earth X person, and they have different layouts.
Okay. So, I mean, you could just do like a when, sorry.
So, okay.
When person is whatever.
Okay.
So
I'll verify the.
Well, so if you
class
want
that
them,
runs
if you want
that.
them in the same list to pass in, then you'd have to do it that way. If you had like an interface here, you could use that,
Right.
or like or say you had like, you want to show a list of people, but then further on, we want to show like a list of hints, because it's like a dashboard, so it's showing some people, but it's also showing like hints. Okay. So none of this has to change. We just add a new section here. So hints, and so for each hint, we would show like a hint view model right here. So the only reason this really ever changes is I'm displaying new pieces or new types of data, and I've created a new model class.
So the rose view is determined by the view model.
Yeah.
And the header will give us new sections.
So I think this is where epoxy really shines, and this is why it's a no-brainer to use it, is because when you're dealing with multiple view types, you can add a new view type in just one line of code, rather than in a normal recycler view adapter, you'd have to change it in like 5 spots.
Right, and you can rearrange them with like Unity, basically. You can change this whole method any way you want. Like, say you want to totally change the ordering, you change this method and it's done. That's all you have to do. It doesn't have to update anywhere else.
It looks like you could also do really easy A/B testing with this as well, by passing in
Sure, so you wanted like you had 2 different types of view models you want to use?
yeah, exactly.
Do that very easily. Yeah, I like that after this method is done, that's all you have to know to decide what's getting displayed on the screen. And it's the only place you have to change things if you want different stuff on the screen. Unless it's, I want to change what a person view model actually looks like. So let's go to one of these model classes. So here's that annotation telling it to generate a model class to back it up. Here's our bind view with butter knife. Just off the constructor jump, butter knife injection, and then we add that text property field here. And here's the, it's not called model prop, it's called, I don't remember what it's called. So that's a really simple example. Anybody have questions on that one? We can also go look at the more complicated examples.
Instead of doing property by property, can you also have a bind method that I do?
So that's the kind of other way of doing it, where you create a recycler view holder class, and then it extends. So let's call it view holder style, and it extends a epoxy spell. Can't remember which one it is.
Got it.
So if you want to do it like yourself, you find views in this constructor here, and then here's where you do the binding part.
Okay.
They have the other one where you can tell it what the data type is with that generic type. So yeah, it supports basically any way you really want to do it. This is just the out of the box works. Lets you not have to have multiple different classes. You really only have your custom view and just a few annotations and some of the gold. I didn't create anything else. Anything else or any other questions on that?
Well, does it handle like drag and drop, rearranging your list?
So I think they have like some special helpers for drag and drop to make it like really easy. But presumably all it's really doing is you're displaying something on the screen and then you're changing the position in the model and it's doing some animation to move the item around. So even if you had to write it yourself, I expect it to be actually really simple to do it this way. Next presentation mode. And just to kind of give you a better example of something more complicated. Oh, let's forget you're modifying.
Have you found any downsides to using epoxy? Like, any sort of like constraints that it's put on you?
So the place that we used it in the main application is on the family page, and it turned some really complicated logic into like really straightforward stuff, and it's doing all sorts of complicated animations, and I think it works out really, really well.
So I haven't really found it running any.
But that was the older version that is a little less magical, so I don't know if the new stuff they introduced is going to cause problems. It doesn't seem like it. It's still kind of doing the same job as before. It just uses the annotations to generate some of it, so you have to write a little less boilerplate. So I don't really foresee there being too many problems. Let's go back to, so this is the sample that they ship. It's basically just like you're adding a bunch of things to this list. Each list is its own, also a list. So you're adding a whole bunch of items to it that are scrollable horizontally. Wait, is that, let me, oh, there you go.
There you go.
This thing does work. You can easily like swap, rearrange them. So I think this is basically just to show off how easy all this is to implement, whereas it would be really complicated to do the regular way of writing an adapter. So let's dig into that a little bit. And it has a lot of features, so it is a little complicated, but a lot less than it would have been otherwise. So this init touch thing is what I think sets up that drag and drop stuff. I'm not going to dig into that because it's actually a little more complicated than the rest of it. But let's go find out where they. Oh, so it creates a controller just as a field on the activity, and then sets it on view. Let's go look at the controller. So here's all the callbacks because you know, just follow good architecture. You want to return all of your user interface interactions back up to like presenter or whatever, so the presenter can decide what to do. So here's their build models. They have that header item. They add these buttons here. So there's the add button, the clear button, the shuffle button, the change color button. And each one of those calls back through that callbacks thing we set up at the top. And then so for each carousel that you created, so every time you click the add button, it's going to create a carousel. And so for each carousel, we just create a new carousel model group. So model groups let you like group pieces together that should be kind of treated the same, or I think it's what lets you do the horizontally scrolling lists as well. So let's go look at how on add carousel like this is implemented. So when they click to add a new carousel, we just create the model object, or like the backing data object, which is how many items should be in there. We add some random color to it, and then we add it to the list of carousels, and then we tell it that we made a change. So all we're doing here is, like when it gets clicked, we just update the data and say the data changed. So everything else that happens is just strictly flowing from the data change. Let's see, let's look at maybe the shuffle one. So if I click on the shuffle button, all we do is shuffle the array. Like the backing where the data is, we shuffle it and then we say that the data changed. And we get those automatically, those nice transition animations for everything bopping around. Let's go look at a carousel model. Oh, this is the generated one. Must be this one. Oh yeah, okay, so here's the carousel like backing data thing. So it takes the actual data object and then those callbacks in case we need to notify about like the colors getting shuffled or whatever. So this looks very similar to the other model, sorry, the kind of the top. So we have this top level one, and then now we're looking at this piece right here. So that's setting up all the listeners free from those. And again, these are going to be, actually, these call back to the same callback. So if you click shuffle, it you tell it which carousel is being shuffled, and it just does the shuffling automatically for you. But you can see that the build models is again really simple. It's pretty straightforward. Like I'm adding these 4 items, and then I'm adding all the colors to it, and that's really all you have to do. It really simplifies how much work you have had to do to shuffle these things around, and then correctly notify which one will change so that you get the nice animations and all that stuff. So any questions about this or any piece that we should go dig into on how this works?
Have you ever tried to override the animation?
Yeah, so if you're doing it that, you probably need to just use like the view holder way of doing these. So if you want to actually, you can do a lot of it just by changing your item animator, because you can change like how a movement animation looks. But if you want like a different animation per view type, then you would probably need to override you'd probably need to use the view holder way of creating your models. But we do it in the our trees app for the family page. There's some custom animations in there, and we're just able to do it pretty easily. Actually, a lot easier than it would have been otherwise.
Does Airbnb have a good amount of sample code to go out with this library for?
So this is all like their sample code here. And then they actually have really nice documentation for it as well.
Do you know have you seen, they do like, collapse items with another list?
If you're going to collapse items.
Well, yeah, if one of the, samples will do that.
Oh, no, I don't think one of the samples does, but I can tell you how to do it really easily. So like you would have, say you have like a list of sections, and each section has a list of people in it. Your section class would just need to have a property like is it expanded or is collapsed.
Oh, really?
And yeah, so your section has some Boolean for that. And then right here, you just say, like if section dot is collapsed, or is expanded probably. Then you'll add everything that goes under it. Otherwise you don't, and suddenly you have collapsing sections. And then your like click listener on the section header would just be change that one piece of state, true, false, or toggle it, and then say that it's changed, and that's basically all you have to do to get these collapsing sections for free. Okay. It's not free, but for cheap. Anything else?
I'm sold.
Cool.
I'll definitely,
in the product.
I know.
I'll definitely try it.
Yeah, I've been really happy working with it, and I think it kind of like fills in a big question mark that we've had. We have this whole architecture, but what's an adapter supposed to do? And I think this really helps answer that question. So, thanks, guys.